You're good to get started, or no?
We're probably good to go. Mentally, I was thinking 205. It's 204,
Okay.
but yeah, we can kick it off. So I just want to thank everybody that is on the call. We will also post this to our website and make it available if for anybody that isn't able to make it or has to kind of hop out early. But EnerChange is funded by Xcel and CenterPoint. We process a lot of rebates. We work with a lot of the preferred utility contractors and the trade allies. And Climate Makers is one of those organizations that we work closely with to make sure that the rebates are um, getting processed on projects. And there's a lot that goes into boilers. So I'm happy to have Climate Makers here and allow them to talk through everything that our clients are seeing and what their maintenance techs are dealing with in the field, and just be able to have Climate Makers be a resource for our clients and then kind of any projects you guys are thinking about. And then we do have with us Evan Fiksdal and then Matthew Josephson, and they'll be presenting, and I'll let them kind of take it away, and you guys can kind of do a bio about yourself, and then just let it roll.
Yeah. Thank you, Ryan. I'll just confirm that my let's see. Everybody still sees the same. Okay. Still seeing it. Everybody sees the screen. Okay.
Yep, we got you.
Yeah. Well, Evan, looks like you're up first.
My name's Evan with Climate Makers, account manager on the service side. So if you have any projects in the future, as far as any boiler replacements, you're looking for here in the near future or need capital planning for in the future, you can reach out to me, get you information on energy savings and rebates and all that to plan ahead. And Matthew is on our control side.
Yep. I'm Matthew Josephson, and I'm involved with building forensics and automation systems and engineering in some of these replacements or boilers if they're upgraded and whatnot. We like to get involved to kind of just do a field verification assessment, just to kind of see what's there, so we can assure that we make the proper recommendations for you on behalf of the rebates and get those calculated properly. So I guess with that, we can roll right into our next. So a couple things, I think we just our agenda, some of the things that we're going to cover today. I mean, obviously the how boilers work and the different types, the high efficiency units versus your your legacy, what I would probably consider legacy, steam boilers and whatnot, how to maintain them. There've been a lot of advancements in controls, and obviously back in the pneumatic days, there were um, um, a few more steps in just assuring that, central boiler heating plants were operational and functional as they were designed and intended to operate. So we're going to touch on that a little bit. We'll have some discussion on annual maintenance contracts with regard to you know anywhere from your old boiler, your steam boilers to condensing boilers. We'll just kind of cut some of those points on that. We'll hit it on a few of the fail points that we've identified on boilers across the board, steam traps, and some potential rebates that are out there for those, as well as other rebates that are out in the boiler world, and then the energy savings you can get with some different approach methods. And then kind of just briefly touch on how and when we get to that point is the right time for you to look for upgrading your boiler and potential replacement or retrofit. So the types of boilers and how they work, we'll just touch on some of that. Um, we've got a fire tube, a water tube, sectionals, and then the latest that has been out is the condensing boilers that has started to get some, I don't know, some traction here over the last 20 years. So this is typical of our some vertical and horizontal condensing boilers. We'll go into a little bit detail of the heat exchange and how that works in some of the other slides. But if you're concerned about a footprint and you're like most mechanical rooms in every building that I've ever been in is you're always at a short square footage for your real estate there. So there are some good vertical applications as well as horizontal applications for any of these new types of boilers. So water tube, I guess obviously, and copper fin tube, just like they say, the water is circulated through the tube, through the heat exchanger. The heat is introduced around it. These are both in different kinds of construction. Some of the heat exchangers, stainless steel, different grades of stainless steel, and as well as a copper fin, different grades of that, just to be able to withstand the difference in heat as well as the byproducts of combustion and assuring that they're able to withstand those extremes. Here's an example of one of the cast aluminum and cast iron sectionals, and they've come a long way as well. The aluminum sectionals, obviously, there's a different thermal conductivity that a lot of these engineers design around. That some have better ability to conduct heat and than others, and there's some advantages to that, and there's also some disadvantages to that. Not necessarily disadvantages as well as things that need to be on your radar as far as a maintenance perspective from regards to good water quality and good water treatment from a chemical provider as you're going through the annual stages and annual inspections and of the boilers. It's something to be conscious of, and we'll talk about that a little bit more in some of the other slides too.
Hey Matthew, do you mind if I ask a question?
Oh.
I assume it's okay to interrupt. These sectionals, are they high efficient as well? Can you get sectionals that are high efficient? You said aluminum. I was wondering if they make them high efficient, or are they just all standard efficient with the sectionals?
They do have some higher efficient high efficient heat exchangers coupled to them.
Yep.
So they are a sectional type of a what I would call the primary the heat exchanger, and then there's a secondary heat exchanger that's coupled to them.
Got it. Okay.
Yeah.
Thank you.
Yep. Plenty of these out there, the atmospheric boilers. And, these require, a couple things, they're generally a cast iron, sectional, some of which, depending on how big they are, they actually need to be, assembled, um, uh, in the boiler room. So the sections would actually be, brought down so they can get through a doorway or down a wherever. And then they're pressed together, and then the jacket is, bound around it. They do require, obviously, some safety interlock controls for, not only boiler room ventilation, but boiler room combustion air. And they do have the ability to modulate somewhat, not near the turn down that you could get out of a condensing style boiler, but there's plenty of these still out there. And as I literally found out last week, there's plenty of them that are still going in. So they'll be around for a while. We'll see them for a little while. So in a typical condensing boiler, the process is basically removing the residual BTUs from the combustion gas. So you can see on the side where your burner is nice and hot, and you're getting hot combustion gas coming off of that. And so a portion of that in some of these other designs, whether it be a fire tube or sectionals or atmospheric, the efficiency is lost. So you'd get 70% of your efficiency, and 30 of it would basically go right out the flue. And with this design, condensing boiler design, they're extracting the additional BTUs through a secondary heat exchanger by way of introducing the return water flow, which is intended to be significantly cooler, right? Where it condenses and removes the existing BTUs. Remaining condensate is then drained out, and it's a much lower temperature of flue gases. Generally, like you say, you have to have a good approach for the condensate removal, because that's unless you're above that condensing point, which in a lot of cases you'll replace a condensing boiler that may operate for 50% of the time during a year where it may not condense, and I would think of that as like over winter months, when you need to have a little hotter water temperatures. But we're really getting the benefits out of that is in the shoulder seasons, where it's the heating demand and the heat required to maintain building temperatures. You can run the water temperatures a little lower. Thus, you get the efficiency out of a boiler with a condensing style boiler. Okay.
So you're saying if I run the boiler runs 170 year round, you're never going to get any condensing, right? That's not a high efficient situation.
Yeah. Yes, correct. Yeah. And we'll touch on that a little bit, because I want to make sure that everybody understands that too. So condensing boilers, fueled by gas or oil, and they get the high efficiency, which is claimed to be upward of 90%. And that value is directly related to the water temperature of your return water. So yeah, like Jeff was just saying, if you're returning water that's 150 degrees, um, you're not going to be condensing, right? Um, the intent of that would be, the ideal target, I think, would be down around 100 to 120 degrees. And I know a lot of you probably think, well, how can you do that? Well, there are ways to do that. It comes with engineering a different approach where you could extract those other BTUs out of that return water, even for if you're satisfying your building, say, for example, running it through plate exchangers for domestic water or some other approach. So there's ways for you to utilize those BTUs in other places to get the efficiency out of the boiler seasonally. So um, we'll talk about that a little bit more too. But the condensed vapor leaves the system in a liquid form and drain. And in many countries, condensing boilers have been around since I think I think it was in Denmark in the 70s, believe it or not. So in the 70s and 80s, that's where they've kind of their infancy began, just due to the added cost, right? And then they started spreading over Europe, UK, and I think what happened is my recollection is like since the 90s, late 80s and 90s, they've actually made them mandatory there um, for the basis of design if you're using a boiler. So um, are we a little behind? Well, I don't know. I guess that depends how you look at it. I would probably say so. Um, but they've definitely um, got some really good traction here in the last 25 years. Um, some differences with condensing boilers is in the venting. Now there are, depending on your BTUs, smaller residential style, say for example, will it's allowable to vent the exhaust gas with a PVC or a CPVC type of venting. Um, and obviously they like that for a couple of reasons. I think that one of the main ones is that they have the ability to control the um, um, condensate. So if the condensate, if it has to go up, 40 feet or something like that, and before it can reach the outside of the building, it needs to, obviously, when it's off cycle, it's going to collect back down at the bottom of that collection box in the boiler. So it going to need it to drain properly. Some of the larger BTU condensing boilers that are out there, especially if they're dual fuel, they require some different venting. And a lot of it is if it's condensing, they may require a stainless steel venting that is sealed with a like a high temp RTV type of caulking. So condensate will drain back, collect at the boiler where it needs to, but yet that in a design day, if you had to run it, that if you needed 180 degrees for your building, it'd be able to withstand the heat of that firing operation at that point. So trying to get some venting that is suitable for the high temp and the condensate collection is something that you'll identify by the boiler manufacturers. But it is something that should all be aware of, right? So as an example of some of the efficiencies, and I noticed the one thing that standard efficiency and the mid efficiency is how they're talking about the minimum return water temperature. I think the biggest thing that kind of falls off people's radar, and I've years ago on many service calls, well, somebody turned down the boiler water. It was not a condensing boiler; it was actually modular. atmospheric. And well, if you don't have 140-degree return water coming back to that boiler, you will condense, and unfortunately, you're going to condense on the heat exchangers, and so then you'll have a lot of soot, and it's tough to clean out. So, on a lot of those boilers that um, some people think they can turn the temperature down, they're actually shortening the life of it and operating less efficiency because they're not within that 140-degree return water temperature range. So that when you look at overall cost, yeah, that's kind of a big maintenance thing where are you going to save a little bit of gas? Yeah, but you're going to pay for it in cleaning all that soot out of that heat exchangers. And that's one slide I probably should dig up and put into this because I've got some pretty good examples of what that looks like. And they're not pretty to look at. So, and like I said, on the far right there with the high condensing, you have you do get a really good efficiency out of those. If you lower, you can get the water temperature. Um, um, the footprint is smaller. I think one thing that jumps out at me is they kind of identify this as a 20 years. I'd probably push that a little bit longer with proper maintenance. And I think that's something that, Evan, you could probably comment on later too. Okay. So this is a AHRI website that will allow you can log into it. You can look basically any piece of equipment that's out there, and you can identify what its performance is and conditions and so on and so forth. If you don't have the website, I can give you a second there to jot it down. It's the ahridirectory.org. So you just input some data, manufacturer, serial, as much data as you have off of the nameplate of the piece of equipment that you're looking at, and then it'll populate a pretty good output. And this is what this particular one, we were looking at a Cleaver Brooks Clearfire that's kind of highlighted halfway down below. Identifies your BTU in, your gross out, your efficiencies, and does give you a lot of data. Talks about what your CO2 and whatnot should be. But this is a good baseline for you to identify some things. And I guess going into this, I think the things you want to identify is if you're in that point where you're kind of questioning, all right, well, what is my efficiency? Starting block might be here. So gather some data, and this is what the baseline should be. I don't know if my next slide goes into that. No, it doesn't. But from this, I would probably take that data and then look at a boiler combustion test and identify, okay, this is what it's designed to do based on what my burner mechanic or my boiler mechanic identifies to me. This is what it is actually doing. And that is a segue that I'm just going to table for right now, Ryan, but that's a segue where we can talk about the importance of those boiler rebates and how those can be effective for a lot of people with regards to boiler tune-ups. It's a very good starting point for a lot of people. So, any questions on the boiler operation before I go into some of the control stuff?
I think that people can unmute themselves if they do have
Okay.
questions. Otherwise, just type it into the Q&A.
Sure. Okay.
Matt, that polypro venting,
Yep.
that's only good for the high efficiency stuff, right? So if they've got polypro venting, or if they're interested in polypro venting, that's probably only good for high efficiency.
Yeah.
I think it's only
Yeah.
good to like 230 degrees or something along that line.
Yeah. Correct.
Okay. But super nice product.
Yeah. Yeah. No, it is.
So it's the physical transformation of water vapor to liquid water that squeezes a few more BTUs out of things.
Yep.
And is there anything acidic about that water, or is it basically distilled water?
Nope. It is very acidic, and that is something I'm gonna touch on here too. But yes, it is. It needs to be. It needs to be put through like a neutralizing, which is basically like a limestone type of um, container. Um, I don't know if they do it anymore, but I know that about 20 years ago, some of the ones that they actually had, they had a quarter inch water that they diluted it with. And so you're basically running water down the drain. I don't even know if those still exist anymore, to be honest with you. But I think um, everybody's really kind of pushed towards the condensate neutralizing they're either a container or it's a module, like basically a piece of PVC that's filled with like a limestone type of filter. So just rolling into some of the boiler controls, I think a lot of boiler manufacturers have kind of wrapped their arms around you know, hey, we're gonna take control of our own boilers, and I think that there was some issues, years of trying to figure out, is control contractors doing the right thing? Should they be doing it? Should they not? Should they have their own? Should they just enable it and then write a set point to it, and then let all the other staging and all the other brains for gas modulation and airflow of the inducer and all that be um, controlled by the boiler itself? And that's kind of what we're kind of seeing, more of a trend of that happening. Um, and I think that there's because they're getting a little bit more sophisticated, I think, and efficient. I think that they need to not put that liability on anybody else. I mean, that liability relies within the master controller of the boiler manufacturer. That's not to say that if you do have an automation system out in it needs to get that information, it needs to collect it, it needs to understand it, so it can either be put into an energy dashboard, or presented as such, so the rest of the building can make intelligent decisions, such as some demand limiting or such like that. So that kind of takes me into this next boiler controls section. If a lot of the boiler controls are take the ownership. In this case, where boiler 1, 2, and 3, the boiler controller themselves will either open a control valve or start a designated pump, or both. They might have a pump and a valve. So that boiler control all would reside between the three boilers. The secondary loop would then be controlled by, I don't know, it could be anything. I mean, this could be a constant volume three-way system. It could be on a VFD. But there would be, in fact, some kind of an interlock to that would say, hey, we've got a boiler plant down. We're going to shut down the secondary system or something like that. So there's logic involved that you can take back and forth from the new boiler manufacturer controller to bring into your automation system.
Hey, Matt, would you agree that relationship between primary and secondary seems to be, if we have troubles with anything in buildings, that seems to be the spot where we come into buildings, it's like that relationship between the flow between primary and secondary seems to be a big point, a point where you really ought to have someone that knows what they're doing involved with this project. Because we see more problems with that relationship in my mind than we do others. Would you agree with that?
We do, and I've seen tons of them like that. So ultimately, it just comes down to the ratios. If you don't, on a design day, if you don't have a 1-to-1 fluid ratio, you're not going to maintain the building, right? So if your building's designed for 180 G or 180 degree water and 200 GPM, but the sum of all your boilers is only 100 GPM, well, you're not gonna get there. I mean, it's, the diversity that's into the end of that design just doesn't give you the, you got twice as much secondary flow as you do primary flow, and you're gonna have a rough time keeping the building up. So it is that with regard to that, that's kind of when I roll in to say, when we're talking about these upgrading the boiler plant or taking steps to do that, it's good to get somebody engaged to just evaluate that, to make sure that is accomplished on a design day. Yeah, no, it's a good question. Lot of this is a variable primary system. Same in effect that, like I say, the onboard boiler sequencer will they'll basically enable boilers and their control valves stage up the burner firing rate as required to see the needs of the system. And generally the system pumps with the VFDs are controlled either by the automation system. I have seen some boiler manufacturers that do take full control of those as well, but not as many. There are most of these condensing boilers have flow sensors built into them, so their ability to identify of the firing rate that they can, and their delta T across it, they can identify that and keep the piece of equipment safe with the onboard controls. So, but this is a typical installation of a variable primary system with motorized valves. And the motorized valves, I think on my next slide, they basically come with the boiler. Yeah, in this case right here, you can see they come with the boiler, and then they just plug. There's a whip that comes out of the back of it, and after the contractor has installed them, then they just plug them in. So it is a manufacturer provided valve, Belimo valve or whatever. So. Now, like I was talking about, how some of the controls on they do have O2 trim. Okay, so just like your car, you got an oxygen sensor in there, and if your mixture is not appropriate, it will automatically adjust the firing rate to maintain that. So it's pretty it is important for you to know that, because I think that's the way that it keeps the most efficient burn going seasonally. And I think, when you're talking about the mass airflow, these boilers will run when it's, minus 30. They'll run when it's, 100. Some of the boilers are out there running at 100. Well, what's the difference between that? Well, it's your volume of air at those different temperatures. So if you don't have any type, some of your conventional sectional boilers or just regular fire tube burners, and a lot of them don't have that. They don't have a mass flow type of burner where they're actually looking at the volume of air. So in some applications I've seen where they would have to get tuned up seasonally. So if you're going into, and this I guess would be more on process boilers, but if you're going into the winter, you'd have to, you know, have it tuned at 30 degrees. And then when you're coming out of the winter and it's 75 degrees, you'd have to have it tuned again. So this control with the O2 monitoring, compensation, and trim automatically provides the right mixture and the right burn at various loads. So that's nutshell. That's kind of just to explain that. Yeah, just a little example of what happens. If you go out of the range, it tries to bring the O2 level and trim back into an efficient operating. This might be a lot, but it's worth just putting up there, I thought. So the controller that's on the far left, that would be identified as your master and slave controller number 1, and the subsequent ones on the far right are slave 2 and 3. These burner controllers, as you'll see on that one on the far left, has its own outdoor sensor. So it does make it pretty clear and cut and concise for you as an owner, of where, if you have somebody automating it or somebody turning it on. Somebody who's turning it on is the relay lit up. There's a switch to close that says enable the boiler plant, and then write a set point to it. This way, it's pretty defined that everything downstream of basically that automation relay is in the boiler controller system. So just to put this out there as a this is how it would look wired. And keep in mind, this is essentially the controllers and wiring that's inside each one of these boilers, and then they're just plugged together, essentially. So so boiler warranties, and this kind of goes across the board with all of them. So I think support maintenance properly is a key. Is there probably anything more than you're doing now? No, I would say probably not much. I think the big requirements of this, like I say, are to assure that you have good water requirements. And so if it's a system that you're taking down and you're going to have it open for a while, I mean, I would want to have the system flush and filled and cleaned and tested for the required boiler manufacturer's water quality table. And that, with that said, that's generally, I don't know which pH and how much iron or calcium or whatever. They just want an idea of these things to not only protect you, but to protect the warranty. And condensing boilers or any of these other they all have this. They've all had this for many, many years. So there is a lot of water quality issues that I've seen across the country, actually, that are one part of the town, it's got more iron than the other, and wondering why the heat exchangers rot out. Well, I think there's your answer, right? So it is something to just on a boiler plant, just to make sure that everybody's conscious of. I think one of the other ones I wanted to touch on was like thermal shock warranty. You're less likely to have thermal shock issues on a condensing boiler because that's what they're designed for. But different from some of the fire tube and water tube, where flow rates are very defined and need to be maintained. Otherwise, there's a higher potential for that shock to happen. And I think, was there anything else on that you wanted to hit on, Evan, or? I don't know if there was any. Okay. So we got to go. I'm trying to find, neutralizer. So the neutralizer kits, this kind of covers a lot of the maintenance stuff. And I don't know if this is something that you want to talk about, Evan, or I can certainly do it too.
Yeah, I can take this one, Matthew.
Okay.
So with condensing boilers, require neutralizing kits to neutralize the acidic water before it gets drained, to protect the drain. And maintenance kits on condensing boilers are really important to do during the tunes, which is a lot of your gaskets, igniter, flame detectors, so forth. Annual tunes, cleaning and calibrating. There are certain boilers like EnerChange out there that I found that some of our customers that have skipped years on doing clean and tunes and with the kits are almost imminent for having problems. Cleaning the filter is important and or changing them. Combustion analysis, we take that to make sure after the tunes to make sure that the boiler is operating as efficient as it's supposed to. And that's what we send in to Xcel or CenterPoint or Minnesota Energy Resources for rebates.
Yeah, and I think the nice thing about that is, I think one of the first pictures they show, they have a really nice filter on it that it's a washable, cleanable filter, and always like to have a spare and just clean it out. It's an easy replacement if you choose to do that in house. But that's a
I would also say, for those that don't know, that acidic condensate will chew up the concrete. So if you're seeing that condensate dripping near your concrete and it's eating up the concrete, your condensate kit needs to be replaced. I mean, you're past that point. So if you're seeing that eating up concrete, that's what's causing it. It's acidic water being drained there. It'll eat up cast iron pipe. It'll eat up the grates. Of course, it's fine if you got plastic pipe, but it'll chew up that concrete. You got a problem. They should be maintained. It creates havoc with your wastewater system.
Yeah.
What pH are we talking about?
Ooh. The pH of the boiler plant water, or are you talking about the condensate?
The condensate that needs to be treated.
That I don't know off the top of my head. I can get that answer for you, though. I don't know what that one is.
I think it'll run in that 2 to 4 range, right?
Okay.
It'll be that low.
Okay.
Yeah. I thought I had a slide in here for that. Did we not? Oh.
So this is a sample of an EnerChange maintenance for either 12 months or 24 months. So they go back and forth in the different type of kits. It's a good representation of time. A solid half day for a technician to go through and do change out what's needed and provide the combustion analysis and the tune-up. And this is for a 1.5, an EnerChange 1.5 or 2 million BTU boiler.
Yeah. Okay. Getting down to the 10-minute mark, so I want to be conscious of everybody's time, but I want to get through some of these.
Condensing
the-
boiler fail points, the biggest things that we see in condensing boilers is electronics. So circuit boards, everything's touch screen now, it seems like. So that's where we see a lot of the problems from the manufacturers. Lack of maintenance is obviously a big one. Got to make sure that your condensate trap is cleaned out. If that backs up, it can get into the heat exchanger and ruin them.
Yeah, and as far as electronics goes, they were certainly a lot worse 20 years ago, and they're I'm not going to say they're not existent, but they're quite a bit reduced of what it once was. So
boiler tune rebates, Minnesota Energy, 50% of the tune-up cost, up to $500 for $1 million plus, and $250 for 300K to $1 million, $50 for less than 30K BTUs. CenterPoint is $300 per boiler, Xcel $250 per boiler, and you need to go through a trade partner like Climate Makers in order to provide these rebates. So we do everything for you as far as paperwork, and either get check or it goes on your bill. It's kind of went back and forth throughout the years. Rebates qualify every other year.
okay. They do have a steam trap maintenance. If there are plenty of those, a lot of those. I think people are aware of them. But obviously there's a testing procedure. And if you're not already doing those yourself, there is a maintenance end. I believe, Ryan, you were going to talk about the rebate for that. I think you might have had that too.
Yeah.
Okay. Some of these are the coming back to some of the considerations for replacements. So I just want to touch on some of those. So there's good benefits to this, right? Okay, there's energy efficiency, and if you have the ability, if you're to that point where the life cycle of your plant or your boilers are, you're getting near, definitely a good opportunity for you to, research as well as incorporate maybe some other energy savings opportunities that may allow you to get extra efficiencies out of the boilers. That one of those I might say is like you say, incorporating some kind of domestic water plate exchangers or something like that into it. There's good opportunities there if you have enough time to put the investment and forethought into just vision where you want to be with it after you're done. So one thing I will say is make sure you have some kind of a set of eyes on it from somebody else. Having somebody literally just last week had somebody replace a like for like atmospheric cast iron sectional, and I just kind of went, well, all right, I didn't know that you were here and nobody knew it, but definitely could have took a great advantage of some rebates as well as energy savings too. Like I say, I see there's some of the things that we see when you start to identify it's that time to make those engage somebody or make some decisions and start to budget accordingly to update your system. Ryan, do you want to touch on this?
Yeah. So there are rebates available for steam traps, specifically for Minnesota Energy Resources. They will cover 50% of the installed or repair cost up to $250 per trap. So that is a very good rebate. For CenterPoint, it's 30% of the repaired, replaced equipment cost. The deadline every year is December 31st, so you have to get that in within that fiscal year. Xcel is $30 per steam trap. They also have a steam trap study program that if you go through with the steam trap study and then you implement replacing them, they'll cover a larger percentage of I guess the total project cost. The rebate on these cannot exceed 60% of the project equipment cost. So sometimes they're kind of playing invoicing jujitsu with that. But then it's also there's a 24-month window to process those rebates. So if any of you guys have done steam trap replacement in the last 24 months and you don't know if you got a rebate, let us know. We can run that down. The rebate deadlines vary per utility, and the biggest thing on our end is to have communication with Xcel, with CenterPoint, with someone at Minnesota Energy Resources to verify if there's still rebate funding available. Minnesota Energy Resources might run out of rebates in September or October, where we just want to make sure that if you're anticipating getting a rebate, that we can actually get it for you. We can go to the next one. Controls rebates. So they're usually custom. So we have to be on the front end. If you've already installed a controls project, we're not going to be able to go back to the utility. For Minnesota Energy Resources, they require pre-approval with us to provide them the scope of the project. It works out to $1 per therm saved. For CenterPoint, it's a custom rebate requiring pre-approval. It'll cover up to 25% of the equipment cost. On that, we're submitting the estimated energy savings for the project to CenterPoint. They'll verify the potential savings. If they can provide the rebate, then they will. Xcel also custom rebate requiring pre-approval. Xcel has an Excel spreadsheet that you can download that is a run through of they're looking for the existing setback temperatures, the number of boilers, number of air handling units, the supply fans that are or the horsepower on those supply fans. And that custom rebate is based on the dollars per kW saved and the dollar per decatherm saved. So we tend to see some of the custom rebates vary from 5, 10, 15% of the project cost. The biggest thing with controls rebates, and I guess a lot of boiler rebates, is sometimes they might not qualify for the prescriptive rebates through the utility, but we can run it through custom. We just have to be ahead of the project scope, where if we get dropped in halfway and a bunch of stuff has already been purchased, then we're not going to be able to make a move. So it's just clear communication with us or climate makers or the utility and just making sure that they happen.
Right. And that kind of brings it to an end. Any other questions with regards to rebates, controls, condensing boilers, approach? I know one of the things you were saying, Ryan, that is really good to make sure that having a boiler replacement, like you say, is one thing, but then how you're going to control it is a part of that prescriptive rebate that you can, instead of just like basically like just doing a normal boiler reset, you can use boiler reset along with, the building demand. If you have the ability to do that as well, that's an added energy conservation opportunity that can get incorporated into that prescriptive rebate. And
Yeah.
I've seen how that did work on a couple projects for us recently. So
Yep. And it's usually a decent amount of savings.
yeah. So
Any questions? Somebody's got to have a question.
So again, in the future, if anyone has any questions, you can reach out to Matthew or I. They're going to send out a link for the YouTube video here if you need any information here in the future. But if you need any information on projects or any type of capital planning or anything like that, please reach out to us. Be happy to help.
Yep.
So you
Great.
would be interested in stopping out?
Yes.
Okay. I just contact you and you'll come out and take a look at my system?
Yeah.
Fantastic.
Hey. Just gonna go back to there's your contact information if you want to jot that down or.
And I'm a little hazy. What's the relationship between climate makers and energy? I don't know the name.
EnerChange?
Energy Saver. Yeah, EnerChange between the two organizations.
Yeah.
So we'll, on a lot of
Go ahead,
these
Dan.
projects, we're doing the custom rebate side of it. And
So
since we're
EnerChange would
funded
be-
by Xcel.
Yeah, EnerChange would, do the rebate portion of it, as where we would, so it depends on it. Sometimes they engage us, sometimes we engage them. And we would, look for one of our recent projects where we just identified the opportunities of complete controls upgrade, new boilers, new chillers, VFDs, all that kind of stuff. And we came up with a good prescriptive strategy to approach to them. That's like, this is going to be the forecasted energy savings. And EnerChange would then perform the rebate tasks and submit them to Xcel Energy. So they would kind of take the lead on that role of it, if that kind of explains it or not.
Are you both nonprofits and both funded by the utilities or not?
No, we Climate Makers is a full mechanical contractor, service shop, plumbing, heating, sheet metal,
Okay.
everything. So it's considered a trade partner.
So if you do come out and do an assessment at a location, where are those costs? How are those costs covered?
How far an
I-
assessment are you talking about? As far as if you're looking to like change out a boiler or what?
But for instance, we have old slant fin boilers and we don't know how many more years we're going to be able to utilize them before we have to upgrade. So if we want somebody to look at our setup and say, you got 5 more years, 10, 15 more years, would that be somebody from Climate Makers that has the expertise for that?
If you wanted to go through and do like a condition report on the equipment itself, as far as going through it technician wise, that would be a chargeable call. But if you're looking at like looking at what's the end of the useful life and looking at capital planning, things like that, that's what I can help you out with, and that would be no charge.
Okay.
Yeah, and I think, I mean, Ryan, correct me if I'm wrong, but I mean, I think I'd probably approach it as maybe, a good opportunity for a boiler tune. Assuming, have you had these tuned up recently or?
Yeah, this year.
Okay. So if
Yeah.
they've already been done and you kind of got that, but whether or not that's,
And they're working okay.
Sure.
It's just like physically how long,
yeah,
things don't last forever, and
No.
it's going to come, their day is going to come. So,
yeah, right. No, I
Yes.
agree with you there. It's good to have some kind of a plan in place to, you know, and not to say that we can't do it when it's, 5 degrees out, but we'd like to have a little bit more proactive approach to most of our
Yeah.
clients' needs.
Yeah, and we can do, use an energy saving calculator to show you what it would be as far as energy savings going to a condensing boiler, if that's the right fit, or a more energy efficient boiler. Yeah, be more than happy to take a look at capital planning and everything on that.
Okay.
Yeah, if anybody else has any questions, fire away. Otherwise, yeah, we'll send out a copy of this, and then it'll go on our website if anybody wants to rewatch it, and then contact information there. I think that in the calendar invite, the contact information is also there, but I can also make sure that that's updated. But I thank everybody that joined. Climate Makers, Evan, Jeff, Matt, thank you guys. It's always a pleasure educating our client base.
Yep. Thanks everybody for joining. And like I say, feel free to reach out with any questions.
Thank you.
Okay,
Thank
thanks.
you.
Thanks.
Thank you.